Hi there. We reached the separation techniques. We talked about mixtures before and we said that they are a physical combination of two or more substances in a way that every substance keeps its identity. Like when you put salt in water, the salt has a salty taste, it stays, and the water texture as well stays. That's why we say that every component keep its identity. Since it can keep its identity, we can separate them. Today we will talk about the separation techniques of heterogeneous mixtures only. To remember heterogeneous mixtures, they don't have a uniform appearance. They have more than one appearance, they have more than one face. What are what are some heterogeneous mixtures? Heterogeneous mixtures, we are going to classify them according to three groups, according to the components, whether they are solid with a solid, solid with liquid, or liquid with liquid. Okay? So I will start with the solid and solid. This means that all of the components are solid, nothing is liquid or a gas. Some components are solid and liquid, yani part of it is solid and part is a liquid. And liquid, it means the two components are liquids. Example for solid heterogeneous mixtures, we have sand and iron fillings or iron powder, and we have rocks and sand. Both of sand and iron fillings are solid. Rocks and sand are also solids. And I'm going to talk about fruit salad also. It is solid heterogeneous mixture. Solid liquid heterogeneous mixtures, it's like we have muddy water, the mud in water, or sand in water, both are heterogeneous. And the last example, liquid heterogeneous mixture, we have oil and water. You can have another example, it's like fuel in water, for example, it can form a heterogeneous as well. Both are liquids. How can we separate a solid heterogeneous mixture made up of sand and iron powder? To separate them, we have to depend on the physical property. Which physical property we have here for sand and iron? Iron is magnetic. It has the ability to be attracted by a magnet. Let's see how can it be done.
Here we have a mixture of sand and iron, and to get this mixture unmixed, one thing we can use or take advantage of is the fact that iron is magnetic, and so I have here a magnet inside a plastic bag, and if I put that in there, we can very quickly pull out the iron out of the mixture, and then all we have to do is remove our magnet from the bag or invert our bag to get the iron fully separated.
So we can separate heterogeneous mixtures or any other mixture based on their physical properties. And here we have used the property of magnetism, ability to be attracted by a magnet. What about sand and rocks? Sand and rocks in the picture, both of them are solid. But what property I can use in order to separate them? The size, yes. So here I can use a strainer or a sieve, and the particles that have a small size can pass through, while those with a bigger size, they will be caught in the strainer or they will be collected in the strainer. So to separate a mixture of sand and rocks, you can use the property of size of the particles in order to separate them by a strainer or by a sieve. How can you separate a solid heterogeneous mixture made up of fruit salad? As you can see, the fruit salad is made up of different colors and different shapes and different sizes as well. Usually here we can depend on the property of size or color in order to, or shape even in order to separate them. But what do we use to separate them? You can use a fork, and by the fork you can collect, let's say, the strawberries. If you don't like the strawberries, you will collect them all based on their color and shape and even the size. Or you can use tongs or something like a tweezer. You can collect, let's say, the bananas if you don't like them or you want to, or you like them and you want to collect them in order to separate the components of a fruit salad. Now we reached solid liquid heterogeneous mixture. And here we are talking about sand and water. To separate sand and water, I use a technique, I call it decantation. What does decantation depend on? It depends on the property of density. As you can see, when I put sand in the water and I leave it for a while, the sand will settle down. Don't forget, it is a suspension and the particles are so big and their sizes are big and they have more density. That's why they settle down or sink under the effect of their uh, mass or density. So, how can we separate them? It's so easy. I can wait for a while until um, all of the sand settled down. Sometimes I need a long time. If you want to be so accurate, you can wait from day to day. Usually, your mom uses it a lot in the kitchen. I will tell you how after some time.
In this video, you will learn how to decant liquid from a solid. Mixtures can form two layers when a solid settles to the bottom of a beaker. To separate the liquid layer from the solid layer, the liquid should be carefully poured off in a process called decantation. It is typical that some liquid will be left behind with the solid.
Can we say that the water collected is safe to drink or clean? Of course, no, but it is a way to separate them. How does your mom use it in the kitchen? Whenever she washes the rice or some kind of seeds in order to prepare them for cooking, she uses decantation. She doesn't use a strainer the whole time. You can see her washing them and trying to let the water flow out or pour the water out rather than using a strainer or a sieve in order to pour the water away.
In
How can we separate a solid liquid heterogeneous mixture of muddy water? Muddy water is another heterogeneous mixture. To separate them now, we are going to use the technique of filtration. Filtration is another technique that depends on the size of the particles and not on the density of the particles. So to separate them, we need to
Filtration.
use a new setup here.
Take a round filter paper and fold it
Let me
into
use
halves
my
to make a cone
arrow
as shown
again.
here. Fix a funnel on a stand. Wet its side and keep the filter paper in the funnel. Pour muddy water through the filter paper. Clear water will be collected in the beaker below the funnel. The clear water obtained is called the filtrate. This method of purifying water is called filtration.
So we can separate a heterogeneous mixture of muddy water by using filtration. Let's see what are the parts of the filtration technique. The parts, first we have a beaker that has muddy water, and then we have a funnel. Funnel in Arabic we call it ema. We place inside the funnel the filter paper. The filter paper usually it has a circular shape, it's like a circle, and we fold it into half, and then we fold it into another half, and we open it from the center to have the shape of a cone, and we place it inside the funnel. And then we pour the muddy water inside it. When we pour the muddy water inside it, depending on the size, the particles that have bigger size will be collected in the filter paper, while the water will pass through. Usually, the solid collected on the filter paper, we call it residue, while as the water collected in the beaker at the bottom and it passes through the filter paper, we call it the filtrate. What property we depend on to separate muddy water by filtration? We use the size of the particles, because sand or mud particles are bigger than water. They are not able to move through the filter paper, and that's how they are collected as a residue. Usually, a big question here, is the water collected in the beaker, as we call it filtrate, safe to drink? Usually it is not safe to drink, but we have a big question here. What about the water collected from springs? It, it is also subjected to filtration by the layers of the ground, but it is safe. Now we reached the last example of a heterogeneous mixture of oil and water. The big question here, does water mix with oil? No, never, right? So we say that water and oil are two immiscible liquids. What do we mean by immiscible? It means that they cannot dissolve. How can we separate them? We separate them by a technique, we call it decantation. But is it decantation of sand and water? No. We call it decantation of two immiscible liquids. But it takes the name of decantation because it depends on the difference in density. Objects with more density will sink, with less density will float, and we use this property in order to separate them.
Separation of immiscible liquid mixtures. Objective: to learn the method of separating the components of immiscible liquid mixtures using a separate funnel. Mixtures of liquids can differ based on how easily they blend together. When liquids do not mix together and form a homogeneous mixture, we say they are immiscible. A mixture of immiscible liquids can be separated using special laboratory equipment called a separating funnel. The separating funnel is a cone-shaped glass container with a globe-like top. It has a stopper at the top and a tap at the bottom. Using a separating funnel, let's separate a mixture of oil and water, two liquids which cannot be uniformly mixed. We'll begin by pouring the mixture into the separating funnel. Next, we'll close the stopper. Shake the funnel gently and set it aside for several minutes. You'll see the two liquids beginning to pull apart. Water, because of its higher density, will travel down into the conical part of the funnel. Oil, which is less dense, will float on the surface of water. Now, we'll place a beaker underneath the separating funnel and remove the stopper. We can open the tap and let the water collect in the beaker, closing it once all the water drains out. The remaining oil can be collected by placing another beaker beneath the funnel. Now the two immiscible liquids have been completely separated. Summary: immiscible liquids are those which cannot be uniformly mixed together. A separating funnel can be used to separate mixtures of immiscible liquids.
Okay, so to separate a heterogeneous mixture of oil and water, we use a separating funnel, and we call the technique decantation of two immiscible liquids. Now it's your turn to draw. As I told you, you are asked to label and to draw the separation techniques. And this is what I'm going to assign in the activity sheet that will follow this video. So we have first the separating funnel. In the picture, they did not put the stopper. I prefer you put it. And then you should put oil and water. Water usually is more dense than oil. That's why it appears to sink, while as oil float because it is less dense. We open the stopper, the water will flow, and then when when oil reaches the stopper at the bottom or the tap, we close the stopper, we change the beaker, and then we open it again and allow the oil to be collected into another beaker. We have reached the end now. Please stay healthy, helpful, and calm.